This video covers the Gay Lussac's problems in the gas laws unit. The first question says, a rigid canister containing a gas at 15 degrees Celsius and 1.8 atmosphere is heated to 110 degrees Celsius. What is the final pressure of the gas? We're going to look for our givens. Also, we know that the canister is rigid, which means that the volume is not going to change. So I see 15 degrees Celsius, 1.8 atmospheres, and 110 degrees Celsius. Degrees Celsius tells me that's temperature. That's my initial condition, so the T1 equals 15 degrees Celsius. My other initial condition is 1.80 atmosphere. Then it's heated and the conditions change to 110 degrees Celsius, so that's my T2. It's asking for final pressure, so P2 is unknown. There's one more thing I have to do before I can use these values. If you have a Celsius temperature, you have to convert that to Kelvin. The way to do that is to add 273. 15 degrees Celsius plus 273 equals 288 Kelvin. Do the same for this temperature value. 110 degrees Celsius plus 273 equals 383 Kelvin. Now I can pick an equation. Pressure and temperature are both changing, so I'm going to use Gay Lussac's law. P1 over T1 equals P2 over T2. I'm going to plug in these values. For P1, I go to 1.8 atm. T1 will be 288 K. For P2, I'm going to leave it as P2 because that's unknown. T2 is going to be 383 Kelvin. There are different ways to solve this algebraically. Some people like to even isolate this variable before plugging in the values. But the way I'm going to solve it is by doing 1.8 divided by 288. That gives me 0.00625 on this side of the equal sign. I like to include at least 3 digits after I hit my first non-zero digit. So 0, 0, non-zero. And then I include those 3 digits at least so I get enough information. Equals P2 divided by 383. I want to get P2 by itself, so I multiply both sides by 383. P2 equals 383 times 0.00625, which equals 2.39 atmosphere, and you can put that in the answer box. Let's look at another question. It says a container of gas is at STP. Its temperature is raised to 168 degrees Celsius, and its volume is held constant. What is the final pressure of the gas? We're going to look for givens in this problem. We have STP and 168 degrees Celsius. But what does STP mean? Well, STP means standard temperature and pressure. At STP, that means that your temperature is 0 Celsius. Whenever you see STP, you know temperature is 0 Celsius. We need our temperature to be in Kelvin, so add 273, and that's 273 K. We also know the pressure at STP. So temperature is 0 Celsius, pressure equals 1 atmosphere at STP. The temperature changes, it's raised to 168 degrees Celsius. We add 273 to get that into Kelvin, and we don't know the final pressure. My units are good to go because I have Kelvin and atmosphere, so now I can pick an equation. Pressure and temperature are changing, so I'll use Gay Lussac's law. P1 over T1 equals P2 over T2. I'm going to plug in these values. All right, so 1 divided by 273 equals P2 over 441. There are several ways you can approach this. You can cross multiply. What I'm going to do is take 1 divided by 273. That gives me 0.00366 equals P2 divided by 441. To get P2 by itself, multiply both sides by 441, and you get P2 equals 441 times 0.00366. Punch that in your calculator, and you get 1.61 ATM, and you can write that in the answer box.